All right, so like we did when we did all the terms, we did general terms, then we did arithmetic, and then we did geometric. So we've just done our kind of general summing. Now we're going to focus on arithmetic series next, and then geometric summing for the next one, all right? So when we are summing an arithmetic series, there are two formulas that we're going to be using. First one is probably the one I use the most. S of n equals n over 2. We've got two sets of brackets here, so we have square brackets around the 2a plus n minus 1 brackets d. So you see there is quite a lot of similarities in that one with the term expression that we have. The second one that we have is useful though. This one you can use if you know the last term in the series, and it saves you a little bit of subbing in. So it's just n over 2 bracket a plus l, where l is the last term in the series that you want to sum. Okay, so all those, the letters are there for you. So n is the number of terms as always. A is the first term, D is the difference, and L is the only new letter we have in there, which is for that last term, like I said. Okay, so example 1, if I want to find the sum of the first 12 terms of the series, 14, 10, 6 plus ... let's write down what we know. We know that we want to sum 12 terms, so n is going to be equal to 12. We know the first term, which is A, is the 14. And by looking at that series, hopefully we can work out D. What is D? Minus 4. Don't forget the minus, it's going down. Okay, now I have enough information in there to use the first formula. Let's write it down. S of n equals n over 2 square bracket 2a plus n minus 1 close bracket d close square bracket. So I am finding the sum of 12 terms. So sum with a little 12, Tom?
Is that in our formula?
Yes, it is. Yep. The number of terms is 12 over 6. Then it's going to be 2 times a, which is 14. Oh, thank you, sorry. 12 over 2. And then, where am I up to? 2a was 2 times 14. Yep. I'm going to make sure I'm on the right track now. I got lost in my momentum. N is 12. Let's do 12, take away 1, and then times d, which is negative 4. You can do that in steps if you like, or you can type that straight into your calculator. Yep, that's what I've got written down. Minus 96. So I guess that's because we're going down in that sequence, and pretty soon we're going to hit negative numbers. And when you do 12 terms, there's far more negative numbers in there than positive ones. We've got a negative sum. Okay, question 2. That's just straight applications of the formula, as long as you can sum in correctly. All right, question 2. Find the sum of the series 52 plus 48 plus 44 plus ... all the way down to that last term of minus 8. So it would be really nice here if we could use the S of n equals n over 2 bracket a plus l. By the way, when I write this formula down, I change that L to a capital L because I do not want it to look like a 1. Okay? So just keep that in mind. It's meant to be a scripty L for a lowercase l, but just make sure it doesn't look like a 1. Don't want to confuse yourself, okay? The problem with using that formula is, even though I have the first term and the last term, what am I missing? The n. Okay, so we've got A is 52. We've got D is, what's D? Negative 4. Okay. And I know a term, the T of n, is negative 8. And I need to work out what position that is in because that's the n I need for the sum. So I have to go back and remember from when I was doing terms, the formula for a term in an arithmetic sequence, which is
A.
Yes.
Plus.
T of n equals A plus. Okay, so I'm going to have to use that formula first so I can work out the n. Okay, the term is negative 8 equals A is 52 plus bracket n is, I'm trying to work out, so n minus 1 and D is equal to negative 4. Okay, so moving things away, let's subtract the 52. That makes negative 60 equals, I'm not going to expand, but I am going to put the minus 4 in front of that bracket because I like it there. Then I can divide by minus 4, which gives n take away 1, minus 60 divided by minus 4 will make a plus 15. And adding the 1, I get n is equal to 16. So it was a bit of work there, but I needed that number, n is equal to 16. Now I can use the n equals 16, a equals 52, and the L is going to be that last term, the minus 8, into that formula that I wanted to use. Okay? You do actually have, if you didn't, you could actually use the first formula here now as well, because you've got enough information to do that one as well. But we'll go with the second formula. So it's sum of 16 terms. N is 16 over 2, bracket. A, the first term was 52, and the last term was minus 8. So I believe that equals 352, correct?
Yes.
Great. Question 3. For what value of n is the sum of n terms of 3 plus 12 plus 21 plus ... equal to 1128? So again, I'm trying to find n. What do I have? I know A. A is equal to 3, first term. I know the difference. What's D? 9, excellent. And I know that the sum of n terms, I don't know what the n is, but I know that the sum is 1128. Now, I don't know the last term, so that second formula is out of the question, but I can use my first formula to help me work out n from here. So the formula is, and I've got quite a few lines for this, you'll need to write pretty small to show all of the steps here. S of n equals n over 2 square bracket 2a plus n minus 1 bracket d square bracket. Okay, let's sub into that. The sum is 1128. N I don't know, so n over 2. Then bracket 2a is going to be 2 times 3 plus, still don't know the n minus 1, and d is equal to 9. Close the square bracket. Okay, first thing, I'm going to do some tidying up on this line, but first thing I can do in terms of solving it is to times that 2 across. Otherwise, if I expand it, I'm going to have more fractions and things in there, which I don't want. So if I times the 2 over, I get 2256 equals n bracket 2 times 3 is 6, and while I'm at it, let's expand this 9 into that bracket, which will be plus 9n minus 9. That will make 2256 equals, in that bracket I have some like terms. I have a 9n, 6 take away 9 is negative 3. Okay, now I have to find n here, so I'm going to have to expand that out and I'm going to get a quadratic. So it's 2256 equals n times 9n is 9n squared, n times minus 3 is minus 3n. Let's put it in order, because I can see the quadratic in here. I want the 9n squared first and positive, so let's leave those two terms together, although I'm moving them to the left-hand side, which means I'm going to have to subtract the 2256 after it, and that's going to be equal to 0. So there's my quadratic, not a nice one by any means. I can simplify a little bit. You can actually divide that whole equation through by 3. Yeah, good. So it's 3n squared minus n, and if you divide that number by 3, you get 752 equals 0. Now, some of you might want to, at this stage, go, I want to use the quadratic formula, which you can, or you can factorize that. No. It's factorizable. You want to use the quadratic formula?
Yes.
Oh.
No. Factorize.
Factorize, come on. All right, so we are looking for 3 times 752. You're looking for two numbers that times to give 2,256, negative, that number, and add to give a -1. Because of that -1, it means that those two numbers have to be side by side. Okay, so basically you can square root 2256. And what's that? What's the square root of 2256? 47. And so it's going to be 47 and 48. Try it. What is -48 times 47? Our number. Okay, so to factorize this, we're going to split our middle term, which will be 3n squared. I'm going to put the -48n and plus 47n minus this 72752 equals 0. And then you factorize that in, oh, thank you. You factorize in pairs from there. So factorizing in pairs, the first two terms, we can bring out a 3 and an n, which will give us n. 48 divided by 3 is 16, yes? And the third and fourth term, we can bring out a 47, which gives us n minus 16 again. So the n minus 16 is a factor, and the 3n plus 47, whoops, I'm having problems writing all my numbers down today. There you go, 47 equals 0. So it's factorized. To solve that using the null factor, see, I've missed a 1 again, keep missing a number. There you go, there's a 16 in there. Okay, to solve that using the null factor, from the first bracket, you will simply get n is equal to 16. And from the second bracket, you would get 3n equals -47, and you would divide by 3, which unfortunately, it doesn't go nicely, but the more to the point is, it's a negative number. And if n represents the number of terms in your series, can you have a negative number of terms? No. So that solution we disregard, so not a solution, because we can't have a negative number of terms. It's the n equals 16 that is our solution to that question. All right, we've got to keep moving. Question 4. We might have to continue this tomorrow after all. We've got the first term of an arithmetic series is 9 and the 15th term is 247. Liam, find the sum of the first 15 terms. So it tells us first term, so that's A, that's 9. And the 15th term, so T15, is equal to 247. I am trying to find the sum of 15 terms. That's the goal. But because it gives me a term, I'm going to, well actually no, I don't have to, because I have an extra formula, don't I? That T15 is the last term in my series. So I could use the S of n equals n over 2 bracket A plus L. I know that n is 15, so it's sum of 15 terms. So it's 15 over 2 bracket. A is 9 and L is the 247. Okay, and that's 1920. Question 5. The sum of the first 20 terms of an arithmetic series is 1660. So let's write that down. Sum of 20 terms is 1660. If the first term is 7, so that's A, find the common difference. So I'm trying to find the D. I do also know in there, if you want to write it down, that n is going to have to be equal to 20 because it was a sum of 20 terms. Okay, so I'm trying to find the D. Which formula should I use? The first one that has the D in it. So it's going to be S of n equals n over 2 bracket 2a plus n minus 1d. Subbing in. My sum is 1660. N is 20. A is 7, so 2 times 7 plus n is 20 again. Let's just change that to a 19 and save ourselves some trouble. 19d, close bracket. So 20 divided by 2 is the 10. So I'm going to have 1660 equals 10. 2 times 7 is 14 plus 19d. And we just want to get, so I'm changing types of brackets there. I'm trying to get that d by itself. So let's divide the 10. That's easy. 166 equals 14 plus 19d. Subtract 14. 19d equals 152. And dividing by 19, you should get 8. So hopefully you'll find, as long as you can identify what it is you have in the question, a lot of these ones are just about subbing in and then equations. You're just rearranging stuff to get the pronumeral that you want. All right, let's keep moving so we can hopefully make this by the bell. Question 6. A pattern is formed by placing pins in a row on a board. The first row has 1 pin, the second 3, and so on in the diagram. Find how many pins will make the 12th row. So our series, if you want to write them down as we're used to seeing them, we have 1 pin, then 3 pins, then 5 pins, then 7 pins, and so on. With that in mind, that means my first term is 1, my difference is 2, and n, because it says I want to find how many pins will be in the 12th row. So n is going to be equal to 12. However, is this a sum question? No, it's asking for the number of pins in one specific row. So I'm actually after the 12th term. For part A, part B is the sum part. So the term formula is the a plus n minus 1 bracket d. And so I sub in 1 plus n is 12, so that will be 11 times by the difference, which is 2. So that makes 23 pins in that 12th row. Okay, everyone's okay? And I'm going fast because I've got less than 5 minutes left to hopefully finish this. Part B. What is the total number of pins used in those whole 12 rows? This is where I want to sum. Do you have a preference on which formula we can use? Because we can use either. We could use the second one, which is slightly shorter, because we've worked out that last term. So S of n equals n over 2 bracket a plus L. N is 12 because there was 12 rows. A, the first term was 1, and L, we just worked out the last term was 23. So there's 144 pins to make up those 12 rows. I should put in there sum of 12. Okay, one more. No, there's part C. Show that the total number of pins in n rows will be n squared. So we're still going to use the A is equal to 1 and D is equal to 2, but we want to find a general form for it, so we're not going to sub in anything for the n. Now, that means we're going to have to use the first formula, though, because that's the one that has, otherwise we need to know that, actually, possibly could use the second one. We do know the, oh no, we don't know the L, because it's a L, it's a general form. So we don't know the L. So S of n equals n over 2. We have to use the first formula. 2a plus n minus 1d. If I used the L, it would mean that I was saying what that last term was, so I can't use that second formula. So subbing in, leaving the n in there, n over 2 bracket, 2 times 1 is just 2, plus n minus 1 close bracket, and the difference is 2. And I just want to tidy that up. So S of n equals n over 2, I have 2a, expand the bracket, will be 2n minus 2. The minus 2 plus 2 will cancel out, and n over 2 times 2n, the 2's will cancel out, and I will have n times n, which is n squared. Yeah? All right, now here we made it to the last question finally. Here is our sigma one. Evaluate the sum from r equals 2 to 44 of 4r plus 6. Now we have just learnt this, and we've learnt that we can work out a few terms in that series just so we can see what type it is. I mean, we know this is going to be an arithmetic because that's the topic we're in, but you're not going to know that on the test. So you need to work out a few terms first. So subbing in 2, because the lowest number is 2, it's going to be 4 times 2 plus 6. The next one's going to be 4 times 3 plus 6. Then 4 times 4 plus 6. And that's probably enough to get the idea. It would go all the way up to 4 times 44 plus 6. That would give us our last term, which might save us some time. Now, working out what each of those terms are, the first one is 14, then 18, then 22, then all the way up to my last term, which is 182. So to sum them, I know A is 14. I know D, what's D? 4. I know N. How can I work out N? 44 minus 2 plus 1. Okay, so I'll write that down just for those of you who might forget. You subtract the numbers, but always remember to add that 1 on, which means that there's 43 terms in that series. And because we worked it out, we know that the last term is 182. We can now use our sum formula using the last term, the second one there, to sum that series. Oh, nearly there. So N is 43 over 2. A is 14 plus L, which is 182. And then it's just calculator from there. We get 4214. So please make sure